And hi. In this video, we will learn about 8.1 to find limits at infinity. So what is limit at infinity? Limit at infinity is when we have x approaches to positive or negative infinity. As you can see here, if we have n as a positive integer and we have function 1 over x to the power of n, if we have x approaches to positive infinity or negative infinity, we will get 0 as the answer. Therefore, we can conclude that if we have limit fx when x approaches to positive or negative infinity, and we substitute infinity into x, we will get 0 as the answer. As you can see from this graph here, this represents 1 over x squared. Fx equals to 1 over x squared. The question asks to find limit fx when x approaches to positive infinity and negative infinity. Therefore, now we can take a look at the x-axis here. So this is the positive, this is your x approaches to positive infinity. So it will go to here. This is where x approaches to positive infinity. Therefore, we know that fx will approach to 0. So your fx will approach to 0. So now we will have limit fx when x approaches to positive infinity equals to 0. Let's take a look when x approaches to negative infinity. So we refer to the x-axis. When x approaches to negative infinity, which is, we will go to the left, you can see that the graph fx here will approach to 0 as well. So when x approaches to negative infinity, your fx will still approach to 0. So we know that limit fx when x approaches to negative infinity equals to 0 as well. So now, let's see example 8. Given gx equals to 3 plus 1 over x squared, find limit gx when x approaches to positive and negative infinity. So now we have limit gx, limit gx, our gx is 3 plus 1 over x squared when x approaches to positive infinity. So now we just substitute infinity into 3. 3 is a constant, therefore it will stay 3 as 3. So substitute infinity into x squared here, so we will have 1 over infinity, therefore that will be 0. 3 plus 0 equals to 3. So now we have limit x approach to negative infinity, where our gx is 3 plus 1 over x squared. So now we still do the same thing. Negative infinity into 3 will still get 3. Negative infinity into x here, we will still get 0. So the answer here is 3. So let's see the next example. Find the limits at infinity for limit 1 minus 5 over x when x approaches to negative infinity. So now we have limit x approach to negative infinity 1 minus 5 over x. So substitute negative infinity into 1, a constant, we will still get 1. Substitute infinity into x, we will still get 5 over infinity. So by using the rules here, the properties, limit fx approach to positive or negative infinity, where we get a over infinity, and here as well we'll get 5 over infinity, and this will be 0. So the answer will be 1. Okay, have limit 2 over x minus 3 cubed when x approaches to positive infinity. So as you can see here, if we substitute infinity into x, we will have an infinite number. You have to minus it by 3 and power it by 3. So now in this question, we know that when x approaches to positive infinity, x minus 3 power cubed will still approach to positive infinity. Okay, because if we substitute infinite number, infinity here, minus 3, you power by something that is big, which is we have 3 here, power by 3, we will still get a positive infinity. So therefore, for this question, we know that limit 2 over x minus 3 cubed as x approach to positive infinity. So this one here, x minus 3 cubed, we know that it approaches to positive infinity. So we will have 2 over infinity. Therefore, 2 over infinity equals to 0. So now let's recap our properties. In this video, we learned that limit fx when x approach to positive or negative infinity, where we get a over infinity, this we will get 0. And we already learned that limit fx when x approach to positive or negative a constant, we learned this in previous video. If we get a over 0, we'll get positive or negative infinity. Okay, so make sure you know how to use these both properties.